Chapter 2, Atoms and Elements. So let's think about a piece of graphite. The lead in your pencil is actually graphite, it's not lead. What would happen if you broke the point of your pencil off and you took that little piece and you cut it in half? And you took one of the halves and you cut it in half. And you took one of those halves and you cut it in half. And you kept doing that. What would happen? This is a question that people have pondered for centuries. Could you keep dividing it forever? Assuming that you had a knife that was sharp enough that you could see what you were doing. Could you keep dividing it forever? Or would you get to a smallest particle size? Well, it turns out you would get to a smallest particle. And that's what an atom is. It's the smallest piece of an element. It can't be cut. It's very, very small, much smaller than you can see with your eye. And the word atom comes from the Greek word atomos, meaning indivisible. So an atom is an indivisible particle. You can't take a carbon atom and somehow cut it or break it and still have carbon. So this is an important idea that atoms compose all ordinary matter. If we want to understand matter, then we need to start by understanding atoms. And that's what chemistry looks at. What do atoms do, and how do they affect the properties of matter? So, back in the 1980s, a couple of scientists at IBM in Switzerland were doing research, and their work led to the development of scanning tunneling microscopy, or STM. I don't know if I've mentioned this to you guys. I'm not going to quiz you on history. I'm going to tell you about some history of chemistry, but I'm not going to test you on that. So here's names and dates. It's fine. It's just here for interest, I guess. So scanning tunneling microscopy. It's a very interesting technique. So we have this tip which conducts electricity, and then we have the surface that we're trying to look at. And the way this instrument works is there is a current called the tunneling current that goes between the tip that's imaging the surface and the surface. And this tunneling current is very sensitive to distance, because what's going on here is that you've got electric current jumping across from the tip to the surface. There's no wire connecting it. That current is very sensitive to the distance from the surface. And so this tip is moved in such a way that this current remains constant. And so here's a larger picture, zooming back. So this rasters across the top of the surface being imaged. So it goes over here and it moves down a little bit and it comes back. And it's moved across in a pattern. The up and down movement is controlled by keeping that current constant. And so they can measure the variation in height as they move it across. Any questions? Does that make any sense at all? It's kind of a strange idea. So this is a microscope, but it's not a visual microscope. There's no lens, there's nothing that you see. It's not just amplified vision. It's actually using a current of electricity to measure height differences. With this instrument, we can image and even move individual atoms and molecules. These are the sorts of pictures that you can get from a scanning tunneling microscope. These are the best images that we can get of individual atoms. This picture is of iodine atoms, those are the green ones, on a platinum surface. You can see they're spread out very nicely and regularly. And this image is the word atom written in kanji characters, Japanese kanji characters, using iron atoms, those are the red or the purplish color, on top of a copper surface. Now, they don't look like spheres, do they? They look like kind of lumpy little mountains or cones or something. And that's because the resolution of this instrument is limited. But when we get an idea of how small these atoms are, even such a fuzzy picture as this is really quite remarkable. So scanning tunneling microscopy gives us evidence that atoms and molecules actually do exist. Atoms are incredibly small, but they are the key to connect the macroscopic, what we can see, the macroscopic world, with the microscopic world, the world that is too small to see with the naked eye. An atom is the smallest identifiable unit of an element. There are about 91 different naturally occurring elements. It depends on how you define naturally occurring. And there are over 20 synthetic elements, elements that are not found in nature but are made in a laboratory. And there's, people who are making new elements just for the heck of it, because it's fun, I guess. It's a challenge.